guys, today we're going to talk about section 3.5, System of Equations in 3 Variables. In previous lessons, we discussed solving systems of 2 equations with 2 variables. The solution to those would be an ordered pair. In this lesson, we're going to look at systems of 3 equations with 3 variables, and the solution to those are going to be similar, but they're called ordered triples. As you can see, we're going to write the ordered triple the same way as we would an ordered pair. However, we now have a z variable or a third variable. In previous lessons, we discussed the substitution and elimination method, in which we'll use a combination of both to solve system of 3 equations. We're going to go ahead and follow these steps and solve for all 3 variables x, y, and z. Step 1 asks us to pick 2 equations and eliminate a variable. So here in problem number 1, as you can see, we have the variables x, y, and z, and we're looking for a simple way to just take 2 out of these 3 equations and to eliminate a variable. This is going to be using the elimination method, in which I think the easiest route to take is to use the first equation. I'm going to just rewrite it as 3x minus 2y plus 4z equals 35. And I'm going to eliminate the y using the second equation, but I obviously need to multiply the second equation by a number in order to do so, in which the easiest way I see would be to multiply the second equation by 2. Remember, you have to multiply every term in the equation, not just one, which will get negative 8x plus 2y minus 10z equals negative 72. From here, I'm going to eliminate the y's by adding these 2 equations. 3x plus negative 8x is going to give us negative 5x. Negative 2y plus 2y is 0. That variable is eliminated, in which that's what we wanted to have happen. And 4 plus negative 10z is negative 6z. On the right side, 35 plus negative 72 is going to give us negative 37. At this first step, we'll call this step 1. We're actually going to save this equation we get of 2 variables on for a step in the future. Step 2 now asks us to pick 2 different equations and eliminate the same variable. So in step 1, we picked equation 1 and equation 2. So now they want us to pick 2 different equations, either the first and the third or the second and the third, and eliminate the same variable, which in our case would be y. In my opinion, the easiest route to take here is now to use the last 2 equations, since I have to eliminate y, and do something similar to step 1. We're going to have to multiply the first equation by 3, and then we could then add the equations together to eliminate y. Negative 12x plus 3y minus 15z equals to negative 108. We're multiplying every term in the second equation by 3, and the third equation I'm just going to copy underneath. As you can see, the terms with the y's have opposite coefficients, therefore we could add these 2 equations similar to we did in step 1 and again eliminate the y. Negative 12x plus 5x is going to give us negative 7x. The y's are eliminated again. Negative 15 and 3z is negative 12z. Negative 108 plus 31 is going to give us negative 77. And again, just like step 1, we're going to save this equation with 2 variables for a later step. It's actually going to be this next step, step 3, that asks us to solve the system of 2 equations with 2 variables. So that would be the 2 equations we have left over in which we eliminated y from. So step 3, we're going to take negative 5x minus 6z equals negative 37, and negative 7x minus 12z equals negative 77. And we're going to want to solve this system of 2 equations. We can use the substitution method if you would like. However, we're already set up for the elimination method. In this case, I think the easiest route to take is to multiply the top equation by negative 2, or just 2, so then we could eliminate the z's since they would have either the same or the opposite coefficients. So if I were to multiply the first equation by negative 2, we would have negative, or if we were to multiply the first equation by negative 2, we'd have positive 10x plus 12z equals to positive 74. I multiplied by a negative 2 so that when I copy the second equation, I could then just add my 2 equations together to eliminate the z. 10x and negative 7x is going to give us 3x. 12z plus negative 12z cancels out. It's 0, so we're just left with x. And lastly, 74 plus negative 77 is negative 3. Now that I only have x, I could divide by 3 and get that x is negative 1. This is 1 out of the 3 variables we're looking for. Let's find the other 2. The second variable that would be really easy to solve for is z, because as you could see when we have the system of 2 equations that have x and z in it, I can now plug my x value of negative 1 in to find z. So this is our last and final step, which it says plug values into one original equation to find all 3 variables. So we're going to go ahead and do our last step here. Step 4. I'm going to use the first equation in step 3, which is negative 5x minus 6z equals negative 37, and substitute x equals negative 1 in. We're going to get negative 5 times negative 1 minus 6z equals negative 37. As you can see, we only have z left over, so we'll simplify and solve. Positive 5 minus 6z is negative 37. We'll subtract the 5 over to get negative 6z equals negative 42, and get our z variable is equal to 7. The last step would be to find our missing variable, which is y, and we're going to have to pick one of the original equations of the system of 3 with 3 variables to plug x and z in. It doesn't matter which of these 3 equations you pick. No matter which one you pick, you should get the same value. I am going to choose the first equation. I'm going to go ahead and rewrite it down below. It is 3x minus 2y plus 4z equals 35. If x is negative 1, it would be 3 times negative 1 minus 2 times y is what we're looking for, plus 4 times, I found out that z was 7, we can now find out what y is. 3 times negative 1 is negative 3, minus 2y plus 28 is 35. I'll combine my like terms to get negative 2y plus 25 is 35. Subtracting the 25 over, we'll get 2y equals 10, and dividing the negative 2, we'll get y is negative 5. Please don't leave your answers as 3 separate boxes of what x, y, and z are equal to. Remember that the solution is going to be what's called an ordered triple. In this case, we're going to get one solution, and the ordered triple is going to be negative 1, negative 5, and 7, similarly to how you would write an ordered pair. So here is our answer. Just like system of 2 equations with 2 variables, we could get one solution, but sometimes we might get many or no solutions. So let's head on to the next problem to see one of those options. Problem number 2, we're going to follow the same steps as problem number 1, in which step 1 says we're going to take 2 out of the 3 equations and eliminate one of the variables. In this case, what I'm going to do is take the first 2 equations, multiply the second equation by 2, and subtract the equations to then eliminate our x variable. So I'm going to first just copy the first equation, 2x minus y plus z equals 1, and multiply the second equation by 2 to get 2x plus 4y minus 8z equals 6. Let's now subtract in order to eliminate the x's. 2x minus 2x is 0. Negative y minus 4y is negative 5y. Z minus negative 8z is 9z. And 1 minus 6 gives us negative 5. We're going to need to use this equation in a later step. So what I advise you to do is put a circle or a box around it, and this would be step 1. Step 2 is very similar to step 1, in which we're going to take 2 equations and eliminate the same variable. So for step 1, I use the first 2 equations. Step 2, I need to use 2 different equations, but eliminate x again. So the easiest route I could see to do that is to take the second and third equations, multiply the second equation by 4, and then subtract the equations to eliminate x again. So if I were to multiply this second equation by 4, we would get 4x plus 8y minus 16z equals 12. And I'm going to go ahead and just copy the third underneath. We can now subtract these equations to now eliminate x again. 4x minus 4x is 0. 8 minus 3 is going to be 5y. Negative 16z minus negative 7z is going to be negative 9z. And 12 minus negative 8 is going to give us positive 20. Step 2 now gives us this equation, in which again we're going to use the equation we got in step 1 and this equation we got in step 2 for step 3. Notice since we eliminated x in both of those steps, these 2 equations we have left over both have y and z. So step 3 would be to take those 2 equations and solve that system of 2 equations of 2 variables for y and z, which would then lead us to find our last variable of x. So we're going to just copy the 2 equations from step 1 and step 2 and solve this system. It's already set up for the elimination method, so we will use that. And we could immediately add the 2 equations to eliminate a variable. Negative 5y and 5y is 0. Coincidentally, we're also going to eliminate the z's because 9 plus -9 is also 0. Since on the left side we got 0 because both of the variables canceled out, we get the resulting expression 0 equals 15. In this case, we're not going to get one solution as we did in the first problem. We're going to get either no solutions or many solutions. In this case, since 0 does not equal 15, our answer would be no solutions. What I'm going to ask you to do now is try problem number 3, pause the video, and once you get your answer, go ahead and play the video to double check with a quick little description of the steps. The answer you should have got for problem number 3 is many solutions. In step 1, I chose to take the first two equations and multiply the first equation by 2 so that when I subtract, we will eliminate the z variable. In step 2, I decided to take the first and the third equation and add the 2 to then again eliminate the z variable. There was actually no need to multiply because the coefficients for z was already the opposite. And when we took the equations for step 1 or 2, added them, we got 0 equals 0, which is similar to problem number 2 in which the variables canceled out. However, we ended up with a true statement. Please let me know if you have any questions on the lesson.